Tonight, we journey to the centre of the Earth, taking the Sun and an adventure through the cosmos. Not only within the 3 dimensions that we are all used to, but quite possibly taking in the 4th and 5th dimensions as well. Could this be an episode of The Twilight Zone? Well, only as far as that many of the supposed laws of physics may have to be rewritten. The latest evidence simply does not back them up. Could it be that those controlling the narrative about the world around us want to ensure that we never discover the truth? That there really is infinite diversity in infinite combinations? Do the elite know that the truth will set us free and therefore have to hide it from us, as they want us to remain in total slavery to them? They wouldn't do that, would they? Let's find out as we go on the edge. Welcome to the show. I'm your host, AlexG, and with me is Melissa, who has been taking some questions off our social media and forums for our guest this evening. Welcome, Melissa, and we're looking forward to hearing from you later in the show. But first, let me introduce you to my guest tonight, international speaker and author Manjir Samanta-Laughton. Manjir, welcome to On the Edge.
Hi, Alex. Thank you.
Now, the big reveal today is that you have a new physics theory. Now, people shouldn't turn off, because I know that we're going to make this quite easy to understand so that they actually can talk about Einstein and physics in a way that will sort of probably get them many rounds at the pub. We shall see. But to start off with this, I should say that you're actually not a physicist yourself, are you?
That's right.
So in terms of your background, very briefly, what brought you to the physics world?
Well, I've actually trained as a medical GP.
Right.
My parents are both actually medical doctors, my grandfather, etc. But I got interested in how cutting edge physics like string theory, quantum physics, can actually explain things that are normally seen as esoteric.
Right.
And as a holistic therapist myself, I trained in sort of bioenergy therapies. Initially, I was actually just looking for something that could explain these energy therapies. I could see that they worked, I could see they were effective, and I thought, what if we had brought this cutting edge physics together with the therapy and explained it in a really simple way that even doctors can understand. And then maybe we're getting somewhere. What it led me to was completely unexpected. I wasn't expecting to find a new theory. That was completely left field.
Right, so we'll actually get to that, but in terms of where we're actually at with this, we have image 101, which is the heart chakra. Now, I build this as where science meets spirituality. So in terms of this is a sort of starter for 10. Here we have the picture of the heart chakra, I believe. So how does that fit into the model?
What we're going to be talking about, so this is really where we start and end. You know, so here I was as a holistic therapist, and there were things in the sort of therapy I was doing. By the way, it's the same therapy. My teacher was actually the guy that helped treat Michael Flatley, the dancer. Oh, right. So the same guy actually trained me. So here I was, you know, sort of scanning chakras. And of course, if you mention the word chakra to most scientists or doctors, they'll freak out and laugh at you and think you're talking absolute nonsense. But, you know, they are an ancient concept. So I was looking to see, you know, is there something that can explain these? And the theory that we're going to be talking about tonight actually brings it all together, from chakras that are in the body to outer space to in the heart of the galaxy.
Goodness me. Now, you mentioned galaxies, and I know that the research is based very much on an understanding of black holes and what they are. And from my experience with black holes, which is all science fiction, TV and movie based, effectively these things are just giant vacuum cleaners which suck in everything anywhere near them. Is that the case?
Well, black holes came out of some ideas that Einstein had. It came out of his equations of relativity. So if space and time gets curved infinitely, you know, there was this idea that you'd have this singularity at the centre, and that singularity would have this infinite gravity. So it came out as a sort of theoretical concept that out there in space there were these you know, guzzling monsters with these like singularities at the centre, sucking everything in, even light. And so anything that went across something called an event horizon, you know, would get sucked in, and that's where we get that science fiction sort of picture from. Now, they remained sort of theoretical concepts for many years. You know, we weren't sure if black holes actually existed. Now, what changed is that we got the modern telescope era, and we actually started to look out into space. And, you know, a lot of the theories that are pet theories about black holes and all sorts of things, when we actually started to look and see the, you know, what we observed, a lot of things started to crumble. And, you know, long story, we'll go into it later, but I started to get interested in black holes, and lots of people have a fascination for these things. And, yeah, I noticed that there were some anomalies in the data.
And one word that immediately sort of comes into focus when you're talking about black holes, and I've never heard of it, so you'll have to guide me by the hand through this, microquasars. So what are we talking about with microquasars? What are they?
Well, I mean, a lot of people might have heard of quasars, which are these, what is it, quasi-stellar radio-emitting bodies, you know. So really, it's a lot of things in physics. Somebody discovered it, somebody put a name to it, that person probably died or got a Nobel Prize and then died, even better, and then things like that get enshrined and people go, well, that's what it is and that's what it must be. So what we see is these very bright objects in space, and microquasars, by the sort of name that you hear, are just sort of smaller versions of these quasars. And with these telescopes we started to see into space and started to look at these microquasars. And I was reading an article in New Scientist when the whole thing sort of started to get clearer for me. And they was realising that microquasars have black holes, mini black holes associated with them. So this new telescope era was, instead of black holes being these strange theoretical concepts that might or might not exist, we're actually finding black holes in the centre of every single galaxy, and in all around galaxies of all different sizes as well. And one of these types was associated with these microquasars. So Sir Martin Rees, who was then the Astronomer Royal, actually said if we study these mini type of black holes, we can learn about black hole behaviour in general. So what was really strange, though, is that, as you know, black holes are supposed to be sucking, but that's not how they were behaving. They actually were giving out lots and lots of material. And when I looked at the material, it was electrons, which are sort of matter, particles of matter, almost at the speed of light. Quite interesting, considering you know, the recent headlines. Things called positrons, which are the sort of mirror image of an electron, so that's antimatter. And so people might have heard of that if they've read Dan Brown's Angels and Demons and things like that. So antimatter sometimes makes the headlines. And
so certainly, as soon as you mention that, that's it. It's sort of like, oh my God, that's an end of the world scenario when you've got antimatter coming towards you.
Yes, exactly. I mean, Dan Brown's novel goes into how you can make an antimatter bomb and things like that. So, but in reality, people are always wondering why there isn't more antimatter in the universe. So we had that, and then we also had sometimes gamma rays coming out of these microquasars. So it's very puzzling. Why, if you've got a black hole in the vicinity, have you got so much radiation coming out, and why is it so fast? So those are the sort of things that I was pondering at the time about microquasars. As you do.
I know we've got image 102, which is gamma rays, X-rays, and the Milky Way putting into context. So can you talk us through this image as to what we're seeing there and how this applies?
Well, actually, this is something that I actually predicted would happen quite a while ago. So, so this is actually a picture. Again, it's a picture of from a telescope, and it was. This is actually an artist's impression of something that's actually data that was gathered from a gamma ray telescope.
Right.
So unexpectedly, around lots of different objects in space, you have these gamma ray emissions. So it doesn't matter how small it is or how large it is. This is actually our own Milky Way.
Right.
And so this was discovered fairly recently. So this is yet another structure where you have these, and can you see that there's two lobes there?
Right.
And the headlines at the time were the galaxies are blowing bubbles. Now that was, you know, because they didn't expect to find this.
No.
But if you understand the theory, the black hole principle that you know, we're going to be talking about tonight, you can actually not only understand this, you can actually predict these sorts of things as well. And so in my book,
so you'll know when they're going to happen.
you know why, you know the pattern.
Right.
It's very, very simple. You know, so I actually put a table in the back of my book here, Punk Science, that
right, if I hold that up over there, 'cause I know that's in a good
so
close-up
that was published in 2006.
Yeah.
So there's a table in the back of there of what predictions that I've made and what we should see, and the fact that we should see gamma ray bursts in a bipolar pattern at the level of a galaxy was something that I predicted, because once you understand the theory, the black hole principle, it becomes quite simple.
Gotcha.
So it was really the microquasars back in 2003 that I was really looking at, and that's when it all came together. And I was actually on a break. I started writing the book, and I actually took a break and took my dog for a walk. I was no longer with us, unfortunately, but you know, went out and just decided to sit on the branch of an oak tree. And I was actually tuning into the Earth spin. I know that sounds really strange, but I suddenly remembered the words of the cosmologist Brian Swim, who is out in California, and he said, we never take the time to actually stop and feel the Earth spin. You know, we're so busy in our lives that we don't actually do this. For some reason, I decided that moment was going to be when I tried it. And
I need a flask of scrumpy to get the same effect. But I mean, there you go.
So I'm sort of a bit careful about tuning in now. I don't know what will happen, but so you know, so I was actually sitting on the branch of this oak tree, and then suddenly it all came together. Why all this data? The actual data does not fit the theory, because I suddenly saw. It's hard to describe, but it's almost like I was actually inside the workings of the universe.
Right.
And I actually saw it, I was one with it. And not only did I see how it all fits together, but I also saw just how amazingly, infinitely complex this amazing universe is that we're in. You know, you know, it's so beyond human comprehension. And all we do in science is we go from one level of understanding to the next. And I feel that this, you know, this idea about black holes is the new ideas about black holes is maybe part of this next stage. You know?
The next stage in the development of
next
physics.
Stage of development.
So I mean, in terms of astrophysicists, are they having to change their views from what you're demonstrating to them?
Well, they've actually started to do that. So what my insight was that, very simply, black holes are actually creative, not destructive. And I realised that we're going to talk about the speed of light. That the speed of light isn't the speed limit of the universe.
Right.
And so this is actually not a new idea, because Einstein himself actually said that speed of light, could there be something that went faster than the speed of light? And by this time people were going, no, because your rules say they can't, you know. So even Einstein himself was starting to
almost
question.
a victim of his own success.
Yes,
then
exactly.
It's like, you made the theory, what do you mean you're not sure now?
So, but I got interested about the late 90s, where I should have been studying for medical school finals, but I was sort of more interested in this instead. And a group of physicists in London who were actually saying that the speed of light varied.
Right.
And so a team of sort of, you know, America and London was saying that it's called VSL, the mainstream physicists, and they were saying that the cosmology would make sense, the idea of the Big Bang and the expansion of the universe would make more sense if the speed of light was faster in the early universe.
Right.
And when you actually go deeper into the theory, they were actually saying things that were even further than that actually light is infinite.
Okay.
These are mainstream physicists. They're saying light is infinite and it gets curled up in higher dimensions. Now, we know about this idea of higher dimensions from string theory and things like Kaluza-Klein theory. And so space and time has many dimensions. And in case you're wondering what that means, we're used to saying, talking about things in 3 dimensions, aren't we? We're used to saying, right, I'll meet you, you know, on the Eiffel Tower at 3 o'clock, you know, the 4th dimension is time. So you have to go to Paris, and so you have to find your coordinates in 2D, and then you have to go up to the top of the Eiffel Tower, so that's your 3 dimensions. And the 4th dimension is 3 o'clock in terms of time.
Yep.
So we're used to talking about 3 dimensions spatially and 1 of time. So what string theory and Kaluza-Klein brought in is that you have lots of different dimensions, okay? So what these scientists were saying, and all of these dimensions are all around us, and sometimes they say they're folded up, sometimes they say they're quite expanded. So all around us we could have these invisible dimensions that we just do not see.
And the only thing I can think about, as you're saying it, is time and relative dimensions in space. That's a TARDIS, that's Doctor Who. And all I've got to say is we're now coming up to a break. We'll be back with a couple of your comments and questions. So do buy from our advertisers. We'll be right back. Welcome back to On the Edge. I'm your host, AlexG. I'm here talking with Manjir Samanta-Laughton, all about time, space, relative dimensions. I was having a Doctor Who flashback just as she was speaking. Yes, definitely not going to miss the Christmas special, are we, boys and girls? So, Manjir, in terms of these various dimensions, light, infinite in terms of speed, potentially, not limited, as Einstein was thinking. So how does all that relate to black holes?
Right, that's the interesting question. I'd like to just emphasise that this concept of infinite light and varying speed of light is from the mainstream.
Oh,
so
right.
It's not something. This is people in Imperial College. You know, it's not something from the woo-woo left field at all. This is
the woo-woo left field.
No.
Well, that's a technical term I must quote in future. Yeah.
So these are mainstream academics we're talking about who are talking about the possibility of light being infinite. So what I realised, putting all this together, is that black holes are not the sucking monsters at all. At the centre of them, and we might have the this.
107.
107.
So have a look at image 107. This will bring some context to people. Okay.
So at the centre of them, you've actually got spiral. You've got infinities. You've still got your singularity. You've got infinite light, and light basically spirals through the higher dimensions, and it gets to the edge of our dimension, which is at the speed of light. And I've renamed that the perception horizon.
So that's the dotted line through the middle there.
Line,
Okay.
So that's actually the limitation of our dimension, but it's not the limitation of the universe. So on the other side of the dotted line, where you see the spiral, is where all this dark matter and dark energy reside, where 98% of the universe actually resides. It's there, it's just beyond our normal perceptions.
Hence why it's called dark, because we
dark.
don't know what it actually is.
It's actually not dark, it's actually super bright. It's actually beyond normal speed of light.
Right.
So you have this spiral that goes all the way through to that perception horizon, and then the light splits. The light splits, and it goes into a particle of matter, like an electron, and a particle of antimatter, like a positron. And those two are what we see coming out of black holes at the speed of light.
Right.
So what's happened is they've only just slowed down to our dimension, and they also spiral around each other. And that's not the end of the story, though, because they actually breathe. It's a breathing process. You know how the Chinese used to say the breath of the Tao and the breath of prana in Hinduism. It's true. The whole universe is breathing, and the two recombine again, because antimatter and matter are only just 2 halves of light. So when they combine again, they form light, and they give the emission off in the terms of gamma rays. And that's why we see gamma ray bursts all over the sky, because what you have is loads of thousands of black holes that are doing this breathing process and giving off this gamma ray emissions or these electron and positron emissions at all times, at different times. It's breathing in and out.
So what you're actually saying is the whole universe is an organism.
You could say that. You could say that. I mean, it's sort of... You know, I believe everything is connected, and the centre of a black hole is the same centre that runs throughout everything. So it doesn't just stop there, because what I've realised is that you can see an atom this way as well. You know, where we see the quantum leaps of the atom, you know, when you look at it a different way, you'll see the same pattern is happening. What do we get from an atom? Electrons, we get gamma rays and radiation, the same patterns. And also, all the way down, it's like a fractal. The same pattern is happening at every single level, from suns, from stars to planets, to, you know, red dwarfs, you name it. Even our planet's own planet Earth shows signs of that, and we'll go into that in a second. But that's why it's a black hole principle.
One thing to pick you up on, you were on about light going in spirals. So why does it go in spirals?
Why? You know, also it's hard to describe something that is a higher dimensional process, because it is. You know, when you're beyond space and time, how can something move? How can something come? You know, but basically, we have to speak in those terms, because otherwise we can't understand. But the information that's given to me is also everything in nature goes according to what we call the golden mean, or phi, or you know, some people speak about it in terms of Fibonacci series. So
Fibonacci is this where you start with 0 and then you 1 plus your 1, and then you add the 1 and 2 to create the 3.
Yes.
And then you add that number 3 with its previous number 2 to 5, and then you get this sort of number sequence evolving.
Yes.
And this creates that sort of spiral pattern, is that?
This can do, yes, it approximates to what we see in nature. So we ourselves are made up of these patterns, as and again we're quoting Dan Brown, his time the Da Vinci Code, you know, he popularised it by mentioning it in there. So we see this golden mean in all of nature. And you know, the light goes in this same sort of pattern that happens in and in the book I go into proof of how I see that happening, because it also produces the force of gravity. Right. And did you know, I don't know if you knew this, but does gravity go in a spiral? Well, when there's a full solar eclipse, our pendulums and clocks actually stop doing this and they start to do this. Nobody knows why. I really do think that this is because the underlying force is actually a spiral. So that's why pendulums start to do this. When the Space Shuttle Columbia went out, they had some gravity sensitive moss plants. Right. When they were out of sunlight, when they were out of the Earth's gravity, guess what they started to do? Grow in a spiral, because they were tuning into the underlying force. So this, all of the particles in physics, all of the forces in physics are actually due to this one force, this one spiral that comes out of black holes, gets to the edge of the perception, and then it creates all our particles and all our forces. It is one force that's in charge of gravity. Above the speed of light, we call it gravity. Below the speed of light, we call it electromagnetism. And the weak and strong forces. And depending on how you look at it, what angle is what particle you get out. So all of the sort of standard model of physics, all these different particles, it's due to catching that light at a different angle, and that's why they've all got sort of strange, to use the term strange, obviously that's a term of physics. That's a term of physics, but you know, they've got some properties to them which are sort of we can't explain why that particular value. Why does a muon have that particular mass or charge, or you know, that sort of thing? It's a puzzle to us. So
I mean, what we're basically saying is there's so much that physics doesn't explain from what we've got. Anyway, I'm conscious of the time. I wanted to sort of go over to Melissa, who's got a couple of points from our forums and social media. So, Melissa, what do we have for round one from our assembled numbers?
Just one question for round one from Steve Shaw, and he wants to know, what is your view of the CERN scientists who have been using the Hadron Collider to search for the Higgs boson, otherwise known as the God particle, and do you think that the nature of spirituality can be so easily quantified?
Ooh, well, there's a two-parter if I've ever heard one. So those strange scientists, am I allowed to say strange? I don't know, but there we go. CERN scientists, they're hadron colliding over there, and the Higgs boson God particle, is that ever going to appear to them?
Well, I mean, the God particle is that's the name that's given to it, and it's a great headline, isn't it?
Yeah.
But
yeah.
They're looking for why mass exists in particles, and you know, the standard model in physics, which is the one that explains a lot of the forces, it's taken us a long way. It doesn't explain everything. There are a lot of shortfalls. It's not very elegant.
Yeah.
But you know, one of the things they're looking for is, well, what gives everything mass? I think they're putting a lot of money and time into the wrong route, personally.
Right.
And so when you've got a framework, as I said, people start to get very narrow-minded, and they put a lot of money into this framework, and they're frantically looking for something that will make the framework correct, instead of thinking maybe our framework is wrong. You know, maybe the observations are showing us a different way. You know, but a lot of funding goes backing into this one framework.
Yeah. So they're trying to fit everything into their established model, rather than go, what does this actually tell us?
Yeah.
I see.
So they need to find this Higgs boson, otherwise, you know, their model might not add up fully. I mean, it doesn't explain everything anyway, you know, but it's one of the key aspects. How does everything get mass?
Yep.
I believe the reason why we have mass is below the speed of light, that split that happens, that actually gives the mass and the charge. It's that split of the light that is under C, which is the speed of light. You know, when you get into this dimension, mass is possible. So it's a different framework. So for me, it's kind of like barking up the wrong tree. I'm sorry.
No, well, that's all right. That's all right. I mean, loads of money saved straight away when you go in charge of it. Yeah,
yeah,
definitely.
I mean, the interesting thing, a lot of science over the years has been done by insight. You know, with people actually seeing into the universe itself. It's a lot cheaper than digging lots of tunnels. But if you look throughout the ages, you know, people had dreams, people had insights, and that's what really moves science forward. At the moment, how science is done is people start to think, oh, I think I'll invest in this framework. I think I am imposing that the universe works like this. I will go prove it. Rather than listening to the universe to see what the universe itself is telling us. And what's happening at the moment is all of the observations, all of the data isn't adding up to the most cherished theories.
And this comes back to the idea of science meeting spirituality in terms of I think it was Einstein who is famously quoted as saying, you cannot solve a problem with the same level of thinking as where the problem comes from. So you've got to go to a higher level. So in effect, that's what you're actually saying from that.
Well, you know, we are into that now. People are watching this show. People are watching this channel. People are waking up. The framework of people's consciousness is different now. People are thinking differently. And, you know, I've been in this sort of field for over 15 years, and many people are sort of spiritually waking up. They're becoming aware of other realities other than the three-dimensional reality. It's happening. Some people aren't really sure what's happening to them and are getting a bit afraid, but there's a vast amount of people who are starting to wake up to this. So when you have these other experiences, science always starts with observation. You know, so my observation of the universe might be different from, say, Richard Dawkins' observation. I've actually had the chance to ask him this. So
yes, and you can see, I think you can see the clips on your website. I think. Yes, yes.
So, you know, the observations of some people might be that angelic experiences, you know, they may be having connections with angels or some spirit guides, or, you know, so science always starts off with observation. This person has had an observation, how do we explain this? So it's not outside the scientific method to start with that and go, well, is there something that we can say to explain this? So what's so interesting is that mainstream science itself, with quantum physics and loop quantum gravity and all these exotic things, is actually weirder than people, you know, expect. And when you look at these things, you've got mainstream physicists saying the universe is not solid. The universe is made up of processes. It's made up of energy. It's made up of lots of empty space that we don't know what it is. That's weird.
So we're getting into holographic projection then,
Yes.
as a theory, in terms of that our reality is...
Absolutely.
The phrase "life is but a dream" came into my mind when I thought of that, because we're actually saying that everything effectively is relative.
Yeah. Exactly. The public think that science is about being very solid and measurements and things like that. Actually, the cutting edge of mainstream science is saying that things like you just said, is the entire universe a hologram? When you get out there, it's very, very weird. But we're not talking about non-academic scientists here. We're talking about the academic mainstream, and they're coming out with some very, very interesting ideas. You know, non-locality, about particles being connected, no matter the distance. That's been with us for a long time. So, yeah, when you get into mainstream science itself, it starts to look very much like what mysticism has been telling us for thousands of years.
Goodness. Going very quickly back to what you were saying about black holes, did I note somewhere that the centre of the Earth is actually showing some black hole principles, dare you want to say?
Well, it's if I'm saying that the whole universe works in black hole is now a sort of misnomer now, because we're talking about a creation process. But if I'm saying that everything all the way down from central black hole to atoms to even smaller than that is working on the same principle, well, our planet should be doing that as well. Surprisingly, we've got quite a lot of evidence for that, which is quite amazing, because we have in the Earth's upper atmosphere, for example, I think we've got a picture of that, that's 109.
109, okay.
Yeah. We've seen we've got lots of satellites in the Earth's upper atmosphere now, and we've seen that there are these things called gamma ray bursts associated with types of lightning that we've never noticed before above the clouds in the Earth's upper atmosphere.
Right.
So you have this projection, this ELF that you can see there, that red radial expansion, that's going at the speed of light.
Okay.
You know, so you've got the same processes happening in the Earth's upper atmosphere, from the gamma ray bursts that are just as powerful as the ones that we see out in space. Isn't that amazing?
Incredible.
You know, in the Earth's upper atmosphere, you've got these sort of jets that are coming out, and you've got, of course, lightning, which we also have a...
So 104.
104.
And I mean, this is a spectacular thing when people ever see lightning out and about.
Yes.
And this is an excellent example of that. So
exactly. The power of that, and that is an electron discharge. We talked about electrons coming out of black holes at the speed of light. So by the time that lightning gets to the Earth, the measurement is that it should be around a third the speed of light. So we have electrons at almost the speed of light discharged gamma ray bursts in the Earth's upper atmosphere. Isn't that amazing? So I don't know if everybody knows this, but the standard explanation of lightning is that charge builds up in clouds, and then after a while, like static electricity, that actually discharges to the Earth. Now, people have actually tried to measure these with sort of kites and things like that, special kites, and some people have actually got electrocuted doing this.
And we'll find out more about this after this break. Welcome back to On the Edge. I'm AlexG, and I'm here with Manjir Samanta-Laughton. We've been talking about life, the universe, and everything, and that's a little tribute to Douglas Adams there. But before the break, we were talking about what people think lightning is. Now, Manjir, enlighten us. So we've heard the official line on what lightning is. What's your alternative view of what lightning actually is?
Well, there isn't actually enough static electricity produced to produce that sort of force. So I do think it's another example of this black hole principle happening on our actual planet. So in the Earth's upper atmosphere, that you've got the signature of fast-moving electrons, gamma ray bursts, you've got the movement at the speed of light, and even there's some suggestions that there's a different type of lightning that was involved in the shuttle disaster
Really?
2003.
Right.
I'm speculating, that's speculation on my part, that was actually antimatter lightning, because it's called negative lightning, and people think that that's a particularly powerful lightning. So if you put all those into the equation, we have all the elements of black holes actually in the Earth's upper atmosphere. It was such a surprise to NASA that they've only just last year put out in 2010 put out a telescope to investigate this. They were so surprised that this was happening in the Earth's upper atmosphere. Right. And we do, to answer your question, we do also have some early data coming from the centre of the planet to suggest that there is antimatter coming out of the centre of the planet as well. I think the whole planet is actually a system of black holes on black holes, or weather systems. Yeah. You know, the way that people talk about the Bermuda Triangle and things like that.
Oh, right.
I think these are places where antimatter and matter and the gravity and anti-gravity are coming a bit out of it into different balance. So when you have... Right. And don't forget that all of this is breathing, all this is fluctuating. The Bermuda Triangle won't be dominated with anti-gravity at all times. There'll be certain times where it's dominated with anti-gravity. Could this be why these planes and craft are disappearing?
And all these disappearances, goodness me. Wow. Well, let's see if we can get a couple more enlightening comments from our forums and social media. Here's Melissa, what have we got?
Well, we kick off with Steve Shaw again, who says, do you know if there is any progress has been made on a unified field theory bridging science and spirituality? And Gordon McLeavy says, surely God is the greatest scientist in the cosmos.
Oh, right. God is the greatest scientist then. So not Einstein, who it sounds like has got a few things a little bit awry. What do you think? I mean, is it...
What really bridges science and spirituality is the dirty word in the science, the dirty C word, which is consciousness.
Consciousness,
which is the aspect that nobody in science wanted to talk about for many, many years. Consciousness came in as a big surprise as the result of quantum physics. Right. And so quantum physics found that when you get deep into matter, that probably a lot of people know this, that what we call stuff, everything we see around us, when you get at a deep level, behaves differently depending on how we look at it, depending on how we measure it. For the first time, it brought our observations into the equation, as it were. Right. So some quantum physicists, not all of them, but some quantum physicists started to say, well, what does that say about consciousness? And said that actually consciousness isn't something that just is emanating as a side effect from our brains, which is how a lot of mainstream science sees it, but there's something fundamental about consciousness. Otherwise, it wouldn't be able to bring matter into existence by collapsing the wave function. So I know it's fancy terms, but all it means is that, you know, consciousness itself is creating the universe, and there's been a lot of sort of films and, you know, what is termed as New Age, you know, about this. But really, when you look at the sort of quantum physicists such as Niels Bohr, you know, they were saying something that really, if you look at it, it's quite esoteric, really, that consciousness itself is bringing matter into being. So once you put that consciousness is fundamental, you then can enter a world where science and spirituality can come together. Because if consciousness is running through everything, every dimension, you then can get dimensions of consciousness, hence angelic experiences start to make sense. Right. If you've got no non-locality and consciousness and everything is consciousness, you've got telepathy. You know, so I know that a lot of mainstream scientists go, no, you can't talk like this, but these are conclusions that real quantum physicists are making.
I mean, this is where the right brain is starting to come into left brain territory, isn't it? This is how it would be described, I would imagine.
Yes, it's unified thinking, and it's unity between, you know, you're not just separating everything out anymore. You know, this is an integrated approach.
And we mentioned the word unified, and of course that brings us to the unified field theory. So is this the extra building block or extra tools that are necessary in order to make that theory actually work?
Well, I think, you know, what I've done completely, as I said, it was a complete surprise to me that this came through. we're never going to get, as human beings, we're never going to see the big picture. I know that. That was part of the vision that I saw in 2003. But we can only take baby steps, and this next baby step is to unite the very, very large, which is the centre of galaxies and black holes, and even larger than that, galaxy clusters, etc. With the very small, with one unified principle. And what runs throughout all this is consciousness, because of course, if you don't understand that there's a perception horizon, if you don't understand consciousness fundamentally, you don't understand there's a perception horizon. If you don't understand there's a perception horizon, you don't understand why most of the universe is invisible to us, why we can't measure it.
Right.
It's because it's beyond our normal consciousness. So this is the way to bring everything in unity, science, spirituality, consciousness, all together into one picture, where we're looking at the very large, all the forces, all the particles, and the very small as well, and we're looking at the human experience as well.
Well, we seem to have handled all the really big topics thus far, which brings me on to probably the biggest of them all, which is the Big Bang Theory. Now, we're not talking Channel 4 sitcoms when we're talking about this. This is the beginning of the world. So I assume that this is also problematic if we apply the new findings in physics.
Well, yes, absolutely, there are problems. You're absolutely right. One of the problems is with Big Bang Theory is that everything's very uniform. If you think about it, if something's spread out, then and light has a finite speed, there should be more patchiness to the universe.
Right.
But everywhere we look, we see that everything's very uniform. Even that, we're looking very deep into space now, and we should only see young stars, if you think about it, because light takes a bit of time to get to us. So we should only be seeing very young stars from the early universe. We don't. We see young stars, old stars, everything. So some people, if you look up this, again, these are mainstream people, mainstream scientists. If you look up the Alternative Cosmology Group, the Alternative Cosmology Group online, they are petitioning for something other than Big Bang Theory to get funding. Because at the moment, if you're not a believer, you don't get funding. But what's happening...
So very much like climate change.
Yes.
If you haven't got climate change in the description of your research project which you want to get funding for, you're probably on a loser. And Big Bang Theory has the same potential then, does it?
It's become a dogma. And the trouble is, now we've got the new data, we're seeing there's a lot of problems there. I mean, BBC Horizon even did a programme last year called "What If Everything We Knew About the Universe Is Wrong?" Because people are questioning it. So with black hole principle, what you have is a continuous creation universe where everything is created from infinity at every single moment and everywhere. So the party's not over. It's not about something that happened 15 billion years ago. It's always happening all the time. And you don't get the sense when you really feel into it of, oh, I'm just a speck on an insignificant rock, It's like creation is coming through you all the time. And I hope that this is very empowering to people.
Well, we've still got some interesting images to sort of fly through. So let's have a look at 103.
Yeah.
So talk me through what we've got here with 103.
Okay. Now this is a WMAP picture, which is anisotropy picture of.
Sorry, what was that?
Anisotropy picture, which is microwave data, basically.
Okay. From
the universe. So the sort of microwaves that we sort of get from our ovens. They're sort of looking at different spectrum in the universe. And this is a microwave picture.
Right.
Now we're supposed to have proved a Big Bang Theory.
Okay.
Back in the 60s, a couple of guys got a Nobel Prize because they accidentally found the sort of background microwave radiation in one of their telescopes.
Right.
And so they just thought it was bird droppings at first. And,
right. Very scientific. Yes.
And then so they cleaned out all their telescopes and they found that there was a sort of background all the time. We pick it up on our TV sets, the old TV sets that have the sort of fuzziness.
Oh, the analog and the ghosting, yeah.
Yes,
I'm
the sort of snow picture. That's supposed to be the remnants of the Big Bang. The interesting thing about the data, though, is because it's supposed to be an event that happened 15 billion years ago, there's not supposed to be any alignments to structures that are now.
Right.
But there are. And Scientific American a few years ago ran a whole article on how there's actually alignments within our own solar system. The data, the microwaves are actually aligning to structures that exist now.
Right.
And worse than that, there's something called the axis of evil.
The axis of evil,
I thought you'd
goodness
like
me. Oh, right.
Which actually shows that, you know, large structures are aligning around one axis, and that's what the data is showing us. So it no longer adds up that this is the microwave data is showing us something that happened a long time ago. There's too many alignments about structures that exist now. And what you see coming out of the Milky Way is microwaves. So I believe that this is a microwave picture of emissions that are given out by black holes all over the cosmos. This is a picture of now, not 15 billion years ago. So the very data that was supposed to have proved Big Bang is actually a bit of an embarrassment, and actually, you know, showing that Big Bang is not the true theory.
So as it was is as it is now,
Yes.
which shouldn't be if the Big Bang theory is correct, because that's all about everything sort of expanding out and constant change.
Yeah. Exactly.
Oh,
We shouldn't see alignments that are to do with modern structures in the background microwave, and we do. And it doesn't fit. Some people want to sweep it under the carpet, but it's there. So, you know, that's what that picture is about.
Okay, whisking through a couple we've got left. Now, 106 then, the core of the galaxy, 106. Okay. So what do we have here?
This is just to show a picture of actually the bipolar jets that are the signature of the black hole principle.
Yep.
Now this is a galaxy NGC 4261, but this is an actual picture rather than an artist's impression.
Right.
You often see this bipolar jet picture coming out, and it's not just there in galaxies, it's also there around stars, around planets, around comets. You know, it's, and as I showed in the beginning, it's actually in our own galaxy as well. So this is a signature of the creation process.
Yep.
These two jets, and I believe it's to do with higher dimensional geometry. By the time it gets to our dimension, it comes out in these jets that are perpendicular to what is known as the accretion disk, you know, which doesn't make sense. So what the cosmologists say is that you've actually, so the astrophysicists say is as you actually have the stuff going down the plug hole, it gets heated up and it actually comes out in these jets. It doesn't make sense because if you were to do that, it would look like a bit more like a Catherine wheel. And you know, being in physics conferences and heard the mathematics, it doesn't make sense. You have to do a lot of contortions to get it to go perpendicular to the accretion disk, if that's the cause. It's actually the black holes are actually the center of creation, and people in mainstream science are so blind usually to what they think is the truth that they can't see what's right in front of them, which is the obvious answer.
And that probably leads us on to picture 105. This again reinforces the idea that black holes aren't what we expect them to be.
Yes, yes. So, I mean, people come up with extraordinary... this is another artist's impression about bipolar jets. So, you know, this is the signature of creation here. Because people aren't expecting this, they come up with extraordinary explanations like black holes burp.
Black holes burp, do they? Right, yes. Okay, fair enough.
So they can't...
They really are clutching at straws here, aren't they? Yeah.
So because the emissions are given out in such a pattern, instead of explosions, which, you know, explode and then fade away, they're actually given out in oscillations. So in order to explain that, they thought, well, maybe they eat some food and then they burp and then they eat some food and then...
This is an episode of Star Trek, I think. I'm sure I've seen it. It's the big planet eater machine one. I'm sure of it. Yes.
It sounds familiar, but it's extraordinary.
Doomsday Machine. That was the one.
They call people like us fringe. I don't know.
It's quite extraordinary. Anyway, Manjir, thank you very much for joining us. Just leaves me to say, don't forget to spread the word about subscribing to Edge Media Online so that people receive it on any compatible computer around the world. Local censorship willing. Get them to find out more at www.edgemediatv.com. Subscribers will have access to more exclusive features as they come live. Now advertisers, now is the time to get involved with this channel. An enthusiastic niche audience awaits news of your product, venture or service at fantastically low rates. And so now it really is under the radar around the world. You've been on the edge.